Next, we're going to investigate the derivatives of the inverse trig functions. Right? Very similarly to how we found the derivative of natural log, we're going to use implicit differentiation to find these derivatives for the trig function, inverse trig functions. So what you have then is, what does it mean for y to be inverse sine of x? It means x equals sine y. Right? Fine. And we're going to do the same thing. We're just going to take the derivative both sides with respect to x. So this is 1, and this is cosine y dy dx. Great, right? So we sort of have a similar situation to what we had before. We have the derivative in terms of y. And we really want the derivative in terms of x. Unfortunately, it's not as easy as it was in terms of natural log, right? Because if I stick that in there, I have a big mess. What I actually have to do in this situation is go back to the triangle, okay? What I really need to figure out is the cosine of the inverse sine of x, okay? So what the heck is that? Cosine of inverse sine of x. So now you have to really think back to pre-calc when they made you do this stuff, right? So if I think about what does it mean there, x equals sine of y, right? That means on a right triangle, the angle is y, right? Sine of y. And what's sine of y? It's opposite over hypotenuse, right? And this is x, so we can think of that as being x over 1, right? So this is x, and this is 1. Opposite over hypotenuse. So very easy to figure out the other leg. Pythagorean theorem. By Pythagorean theorem, this is 1 minus x squared. So that's our triangle. Now, since that's the triangle and y is the angle, we know that cosine of y is adjacent over hypotenuse. So adjacent is root this guy, 1 minus x squared, and hypotenuse is 1. So cosine of y is square root of 1 minus x squared. So that tells me that the derivative of inverse sine of x is the square root of 1 over 1 minus x squared. Not an easy one to remember. Granted. But we expect you to remember it anyway. So I'm going to put these over here. The derivative of inverse sine of x is 1 over the square root of 1 minus x squared. Great, right? So now you can do all 6 of them. I'm not going to do all 6 of them on the board. You don't probably want to watch me do all 6 of them. What I'm going to do is I'm going to do inverse tan, because inverse tan is the next most important, it's actually probably the most important one. The one you see the most often, especially in Calc 2, inverse tan is all over the place. So it is important. You will have to remember, we're going to now find the derivative of inverse tan, and we are going to use the same method. We're just going to write it down. Tan of y equals x. Take the derivative of both sides. Okay, so derivative of tangent is secant squared. So this would be secant squared y dy dx equals 1. Okay? So dy dx is 1 over secant squared y, which, by the way, is cosine squared y, right? And then we have to do the same thing. We got to go back to that triangle. The triangle is different this time. right? Because the x and the y are in different places, because now instead of x being cosine y, it's tangent y. So if we have, y is still the angle, right? But tangent y is what? Tangent is opposite over adjacent. SOHCAHTOA, right? So opposite over adjacent is x over 1. So the opposite is x and the adjacent is 1. And that will tell you that the hypotenuse is square root of 1 plus x squared. Sure, right? That's Pythagorean theorem. Now, what's cosine of y? It's going to be adjacent over hypotenuse. So my adjacent is 1, and my hypotenuse is the square root. And so I want to put that in there, but I don't actually have cosine y, I have cosine y squared. So I have 1 over the square root of 1 plus x squared squared. So then I have a very nice 1 over 1 plus x squared. And that's why it comes up very often later on, because you see this form quite a bit. And then there's also a number of nice things about this inverse tan function, right? Unlike the inverse sine, inverse cosine, and they have these strange domains and stuff. Inverse tan, if you remember how inverse tan looks, it's defined everywhere. So it looks like this. And so if we look, yeah, so it looks like that. Okay, so we'll just leave that where it is right now. And I'm going to go ahead and write the other ones on the board. Technically, you're supposed to remember all of them for the class, okay? Any of them could appear on the final exam, and you'd be expected to recognize that form. In practice, these are the two you'll see the most, but that doesn't exclude the other ones. So you do have to remember them. I know it's a real pain, but you do have to remember them.